Yeah, there we go. Yeah, yeah. I thought I was sharing my face and I was making expressions. All right, so what did I say? What did I say? What did I say? What did I say? Okay, I was talking about explaining what this is about. So you don't have to if you had both of them in the same program, right? You would have when you are making a transfer will have to call our function. Your transfer is calling another function, and the function is calling is inside itself. So that way you would have issues with reentrancy and all. And Solana by default blocks that, right? So if you want that, then so how are we implementing this? We need to have two programs. One program that is the transfer hook program, another vault program. That's the way I would do it. That's why I like to put all the transaction, all the I separate concerns, right? Separation of concerns, everything that has to do with the vault stays in the vault program, and every other thing that has to do with the transfer hook stays in the transfer hook program. So now let's show what that is about. Okay, I'm genuinely tempted to write it over again, but 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 I will not. But I will do um so two programs. First program is a transfer hook program which you want to be interested in later on. And the immediate one that needs attention right now is the vault. What's the vault? You know what the vault is, right? Let me go back to this. I think last week we talked about escrow. Every single thing on the planet, mostly, is an escrow on the blockchain. Every single thing is an escrow. What's an escrow? This is what an escrow is. Run like a 3-year-old, right? Just keeps everything simple. So an escrow is basically a program that helps you make permissionless is the right word. Yeah, basically permissionless or it eliminates the need for trust basically. So you have Toby. I like using Toby. Toby wants to he needs USDC and he has Rapso. So he deposits Rapso and it tells I need USDC in return. I need this amount of USDC in return for my two Rapso that I'm depositing. So all those details stays in the escrow, right? Then Phineas now sees this and comes, oh, I have USDC, the exact amount, 400 USDC. I'm satisfied that he wants 400 USDC for two apps, so right? And it comes to the platform because this amount is locked here. It comes to the platform, it deposits the 400 USDC. He gets his wrap, so Toby gets his USDC, and everybody's fine. So that with this eliminates the need for trusting in the sense Toby says, "Oh, send me your USDC first." Phineas says, "No, you send me yours first." And Phineas sends over the USDC and people put it the story, right? So an escrow of that, right? So what is a vault? I was trying to explain what a vault is. We digressed. A vault is what vault? A vault is where you keep stuff, right? I don't even know why I made that a topic, right? So a vault is where you just keep stuff, and an escrow has permission over the stuff that you kept there. Basically, that's just it. That's it. It doesn't have to be it doesn't have to be complicated, right? So now back to this place. A vault is where you keep stuff, right? And an escrow has permission over who can withdraw, who cannot withdraw, how much this person deposited. But I'm not talking about escrow, so I'll just keep it simple. Even though everything is an escrow, right? There's an escrow, this thing is an escrow, the whole thing is an escrow. And here is an escrow, you deposit to so to get to swap to you swap to so for $500 or whatever so this sitting on right now. $600, $800. That's an escrow. An escrow is in between there, right? So you swap your lending protocols, everything's an escrow. Just building on top of it, right? It's just more complexity on the escrow. So now, first one that they're particular about the vault program. You know what the vault is now, right? So let's go back to vault. Let me put this on different. No, the vault now. You're familiar with Solana. You know how Solana account is, right? So every You don't store things. I think I should have started with this first day, but we are co-founders, right? You already know what Anchor is basically, hopefully. So I don't need to go into details, but let me just do this. You don't store things on. You store things. You don't store things on. You don't want to store things on the blockchain itself. The way Solana is modeled, the account model. You store things in accounts, just like a big computer, like a file system. I have this folder. If I want to keep things, I want to store another file. I store it in another folder. Some folders are executable, like an EXE, a game, a program that runs. And some files are just to store read-only data. Some files are, so that's basically what's going on here too. So you can read from data. There's some data that you can, some files that you read from, some files you execute, they contain executable logic. Some files you write to them. Basically, that's so Solana keeps everything structured that way, right? So this is defining what a file will look like. A file folder, a file will look like. This is defining what a file will look like. So let's think of your accounts as files. Your accounts are like files. Your wallet address, your wallet is like a file. It can be read, can be written to, can be deleted. Yes, that's all. CRUD, create, read, update, delete, right? So that's basically what's going on. And so in this vault, you want to store, okay, this vault can only store this kind of token, that's the mint. Then the vault bump, that's, we'll get to that. Then the owner of this vault, who is the owner of the vault, that's the admin in this case, right? So I was talking about vault bump. When you have a PDA, everybody knows what, I hope everybody knows what, okay, let me just go into this. Now some accounts are system, there are different kind of accounts, like a different type of files. There is, you have Microsoft Office file, you have PDF, you have TXT, different kind of files, right? But they are files. So there's some files that only works with this program. It can only open a .docx file in Microsoft Word, right? So that's basically what's going on here. So with a PDA, as right to write. The thing that can write to a PDA is the program that created the PDA. The only program that can edit a Microsoft Word document is Microsoft Office, right? Just leave it at that. Just leave it at that. So even if you can use what are you using again? What about file editor? If only a file editor program can edit a file, right? Can edit a doc file. So that's basically what's going on here. So this vault, this bump determines what configurations was used to create this file. So when you are reading it and writing it, you know, okay, this is the configuration I was used to create it. So you can use that to write to it. That's basically what the bump is. And you can determine that by your seed. How am I going very low level today? Let's just get started, right? The structure of for the whitelist now is we're going with the same model because we just want to start something right off. I'm going with this initial model that we wanted to fix. So the model is you have a list of addresses that are whitelisted. So now we are now saying, okay, this is the address. Then let's do the also saying, sorry, give me a minute. Also saying how much did you put in here, and are you whitelisted? Legit, yes. Are you legit? So that's what we're doing. We have a public key, that's the user address, then the amount the person is keeping inside of it. And this person actually permitted to send. Let's say you have a contribution system now, people can deposit money, but you don't want them to withdraw the money until a specific period of time. You can blacklist that address from withdrawing. You can just, and the possibilities are endless, right? It's just permission transfer. That's basically what the idea is about, right? So this is basically the information I was storing inside per user. So the user, the amount person is able to, person has deposited and is able to withdraw, then is this person whitelisted? Can this person perform this operation at this particular time? So that's what we're doing. Yeah. So the address is containing the user address, the amount the person is deposited, and is this person whitelisted? Is the person permitted to make this transfer at this moment? Then the bump, the configuration that is to create it. When we want to read it next time, we can just save it, and you don't need to save the bump. You can just always derive it every time you're passing it, but to save compute use, right? To save use, you just save it. Once you create it once, you save it inside the address, whitelist bump, and admin. So now we're looking at, you just have a simple implementation here, right? We want a helper function for this whitelist. So when we create the whitelist later, we can just have access to this stuff. I'm going over the last time. That was 2 days ago. I was supposed to live stream yesterday, but it's crazy. I've explained myself already before. If I just join, you can go back to the beginning of the stream so you get why they are not live streaming yesterday. So it's whitelisted. Also check if this person, you are checking if the first helper function is if this person exists in this array, this vector, right? So if someone wants to make a transfer to your vault, you need to check, does this person actually exist in the vault? Does this person exist in the addresses of whitelisted people, right? Of the address of iterate. So when you get anyone that you see that has the same address as the address that you're putting, just return it back to me and give me if you get it. Tell me if you get it or not. So that's true or false, boolean, right? So the another about function, we need to know that person that you fetched now, is the person truly whitelisted or is the person not whitelisted? So we fetch if the person actually exists in the vector, and also check if that person is whitelisted. So we do the same thing, almost the same thing. We iterate, then we find. So once we find the person, we now want to return the whitelisted status of the person whitelisted or not. So that's what these two helper functions are doing. So I've talked about the states, the two states that we have inside this vault. So the vault state that's keeping track of the money, the tokens, and the whitelist. The whitelist is actually keeping track of the money. And the vault is the state that has what token can you deposit and which are not the vaults, right? So we have an instruction now. So let's start with our instruction handlers. Instruction handlers, librs. The way we do things over at Turbine is uh, this is about turbine is we like to modulate to put things in modules. So I have the instructions over here, and we have our instruction handlers here. So create the vault, then ctx the account dot create vaults, because inside this create vault, yeah, inside the vault operation, inside this vault operation, we have an handler that says create vault, which is an implementation of this struct. We're coming back to that, right? So this is just used. We arrange things and it feels convenient, right? It makes sense. If you did builders, right? Some people do not do builders, and also yeah, so it's not. So we have this is the operations to handler to create the vault to mint tokens. So as an admin, I want to create some tokens and I want to have some those tokens, right? I can mint tokens to myself as an admin. I can add people to the whitelist. That's talking about the whitelist. I can remove a user from the whitelist as an admin, and everybody can deposit, everybody can withdraw the amount that they deposited. So that's basically all the 5 instructions, 1, 2, 3, 4, 6 instructions that are inside this vault program. So we're going to get into the implementation of how they work under the hood. And the next thing we want to talk about is the transfer hook. That's the most interesting part. But I save the best for the last. So the transfer hook, I'm just doing 2 things, 2 instructions. I hope so. So in the lib, you can see two. Yeah, that's correct. 2 instructions. The transfer hook instruction and the initialize transfer hook instruction. Remember last time I said for a transfer hook, you do the transfer hook. Sometimes if you are not using this discriminator to tell the program that this is the transfer hook, you always need to have a fallback function that recalculates. Let me show you how spaghetti that looks. Not spaghetti is Solana program, bro. It's not spaghetti. Respect to the devs. So this is what it looks like. You will need to have a fallback function here. That's we get the instruction that was called on the transfer hook, on the child instruction that just hits the transfer hook. And check for that instruction. if the instruction has an execute, if it's executable. So if it's executable, to get the amount from it. So if it's an executable instruction that you made a transfer, basically it gets it that, and it does this private global transfer hook, all of this. So this is boilerplatey, but it feels boilerplatey, right? It feels like you don't want to understand what is going on. Just copy and paste it in your code, and it works. But this is a cleaner approach to that. With this instruction discriminator, SB instruction, SQL discriminator here, just have to write your transfer hook. Simple. Then the other instruction to initialize the transfer hook. So once you've created a token, remember I'm minting the token here. I'm minting the token here in this instructions. Mint token. I'm minting the token here. Once I've created the token, I minted it, then I've initialized the token, created the mint for the token. I want to add a transfer hook on that token. I need to initialize the transfer hook, right? So that is what I am doing here in this instruction. Yes, it's librs. Yes, so I also repeat. What I'm doing here in this instruction, initialize transfer hook. What it does is get the extra account meta of the that is needed. So what is extra account meta? Just simple English, extra account metadata of the extra account that are required for this transfer. Simple and straightforward, right? Doesn't have to be complicated. I live for simple things, right? I like things simple and easy to explain. I like be able to see something, I be able to just immediately grasp what's going on there, right? That's what that life is good like that, bro. So extra account meta list initialize. So what this is doing is calling the initialize method, and they are saying I want to initialize this extra account meta list on the token. So I'm initializing the transfer hook here. That's basically what this is doing. You don't have to work complicated. Just this is one of the things that you just have to copy and paste and use. But you understand what's going on there, right? So first thing you understand what's going on there, just reuse it. Yeah. So you have initialize transfer hook, then your transfer hook here. So yeah, let's get to the transfer hook. Let's start from initializing the transfer hook. That is from let me click see this this is to this folder looking for ctx account, yes, ctx account extra account metalist. So this is what this is. So this is how I'm initializing the extra account meter. Simple, one of those things that you just have to look at, and this is how it works. So what we're doing is we're creating, okay, before now I just add a straightforward this. What this is I'm telling you that at every instance that this instruction is called, you have to pass a private a public key. So and I'm defining what type of public key I want. So I'm expecting you to give me a PDA on every call to this transfer hook. So once you are making a transfer, as long as this transfer hook has been initialized on the token, once I'm making a transfer, you need to pass this PDA, and the PDA is derived from because I'm not creating if my transfer hook, if it was a regular transfer hook and a token, I'll just do this straightforward, right? I'll just do extra account though with seed. I think I'll just do, let me copy this. Where am I? Where am I? Yeah, I'll just do extra account meta instead of new with public key, I'll do new with seeds. Yes, because this is the seed I want you to create a public key. But because I'm not creating the public key, I'm not creating the PDA, the address with this account, with this program. This program is not the owner of the PDA. The PDA I'm looking for is the whitelist PDA, and the whitelist PDA I created it inside this other program, this week one challenge program. Now. So I need to specify and tell this guy that, bro, where's it, bro? I need to specify and tell this guy that, but there's a more efficient way to do this. I honestly always want to avoid doing this. Find program address on chain. It consumes CUs, right? So you don't want to always do this. If you can just use it what is saved somewhere and save it and use it. That's better. But I just have to do this to make it work, right? This works. It works, but it's not the most efficient because it's expensive. Everything is expensive on chain radar. So you want to limit the amount of, if you don't actually desperately always have to do this, you could avoid it. That's what program that was saving thinking making programs, efficient programs is about, right? So when you're creating an account now, you don't want to always derive the bump. Basically just create the account once, save the bump somewhere and reuse it over and over, instead of just creating initializing the bump, getting the bump and finding. This is basically what Anchor is doing every single time you are doing that. Create account and putting bump, it's doing this and getting the bump for you. So mostly you don't want to always do this, so you just save CUs. Why am I rambling on about this? So I'm telling it, for every instruction that's coming to this program, I need a whitelist public key, a PDA that is derived from this whitelist string buffer. And the person that created this ID, the person that created this address is this other program here, because I'm not this transfer program is not where the whitelist address is living. You could do it that way and put all your votes inside that vote program, then put initialize whitelist inside transfer hook. But I just like to keep it transfer hook does transfer hook, vote does everything that has to do with vote, right? So I'm creating the whitelist inside the vote, the other vote program, and I'm telling you whenever I'm making a transfer to this program, always pass the whitelist account. That's basically what I'm saying there. So I'm telling you, it is not a signer, but it is writable because I want to update it, because you're adding to the PDA, right? You want to update the PDA. You are saying once a user make a transfer, you want to edit that PDA and say, oh, I made this transfer. This user made this transfer, and this user is whitelisted, right? What we're doing that whitelist. So that's what I'm doing here. Then the accounts that are required for this, the signer, the person paying for the transaction, right? The extra account meta list. So that is you're going to pass in extra account meta. This one is baked in stone. You don't touch this. This is how you derive the extra account meta list. Extra account meta list is an account that holds all the extra accounts that are required to make this transfer. That are required, all the extra accounts that contains the hooks that are using in this transfer, right? So extra account metas is what it is called. Must use this seeds. That was it says. Must use this seeds. Then the mint of the transfer they are making in system programs. So that's basically straightforward, self-explanatory, hopefully. So if we've created this, we've explained what initial extra account meta list does. So now let's move on to the next one, transfer hook. Because we have just two instructions in this folder, right? Then the transfer hook is actually the logic that gets called immediately make a transfer. Immediately make a transfer with the token program. The logic that gets called immediately. That is what the transfer hook is. Excuse me. So let's see. Let's go into that. We have source token, and this is exactly how it is arranged when you're making a transfer. Source token is the first account, mint the second account, destination token the third account, owner fourth account. So index 0, index 1, index 2, index 3, index 4, index 5. This is what extra account you need when you are normally to stop here. But if you have extra accounts that you want, you can always add them after all of this. So the first one will be extra account meta list, just to keep things structured so you don't start looking for where is what. Because in when you're initializing your transfer book here, in this place now, if I wanted another address to be, if I wanted it to pass another address, I always want to make sure you're passing that address, right? I will have to do this here. I'll say after I pass this, now also give me, effect of that. So also give me Also give me a minute, an address, new with seed. I want to create a PDA. Also give me this PDA that is created from this seed. So this one you're not passing the address, you're passing what's it case new with seeds. Let me check. Resolve this for me. Resolve this for me. My link that's not working. So it is I think account. It's not is it account from no that's not what it is. But it's something like let me just get it from Andre's last month. Whitelist. Okay, this is cheese. Let me show you what that would look like in a minute. You have it here, so let me just show you. Mm, instructions. This is cheese work, by the way. Chief foods. The instructions of the transfer hook, not of the vault. Yes. Let me show it. Let me just show it. Instructions of the whitelist of the transfer hook. I think the transfer hook is inside the whitelist. Yes. When is initializing whitelist? Yeah. It's saying that you must pass. Where is it? 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 Look at me jumping into someone's code without knowing where what I'm looking for actually is. Initialize whitelist account. Blah, blah, blah. Fetch account. No, I think she is using a different approach. Is this? You always want to know what you're looking for in someone else's code, right? Um, let me use Andre's code. Andre. If Andre, give me a minute. Let me find. Let me look for it. I want to show you exactly what that looks like, so we can just give me a minute. GitHub. It's my GitHub. And whitelist transfer. Escrow whitelist transfer. Initialize. No. Back to whitelist transfer. I need Andre's program. Andre's program. Yes. So this is Andre's program. Muhahaha. So in Andre's program, we have the example that was given to RIP. So in his instructions, where is initializing the extra account meta, is doing yes, is what I'm looking for. Seeds the extra account with meta with new seeds, right? New with seeds. So what you are doing there is essentially using the same new with seeds, you're using new with seeds, and you're passing this all of this. You're saying now the seed I want to create this with, if you have different seeds to be this seed, then the next seed, then the next seed. So if this one is just one seed, right? So the seed is of a seed literal seed from the bytes. This this is the same thing as doing this right here. But because you're inside the extra account method, you have to do it the way it's provided. You have to specify the kind of seed because that's a bit type of this seed. So now this is exactly how it is done inside the extra account meta. You are passing this seed, you are creating one account with this seed. So what I was trying to explain was this is our code. This is not our code. This is our code. This is our code. So if I add other accounts here, if I need other accounts here, I could I'm trying to explain something now. I forgot what I was trying to explain. Uh but I just showed you how you can add have other accounts. Okay, I think this I was trying to explain that you can pass other accounts here. So you can pass other accounts here if you need other accounts, not just the whitelist. If you need other accounts, once you pass in the whitelist, you have to pass in another PDA that is derived. Okay, yeah, derived with this address, right? So you will use this. I'm trying to explain. So this one derive this PDA for me with this buffer, and the owner of the buffer is this account. So I'm not passing any owner here because the owner that is deriving this account is this guy. So that's what you will do with that. But now we are deriving it with a different account. We're deriving with a different account, so we have to use new with pub key, not new with seed. Else it will derive the account with the seed for this account. So assuming I was doing new with seed, I'll just put this here as I think it was this. Yep. And you can say seed. Yeah, I remember now. After I've seen it. From literal, yeah. Then the byte is buffer of this guy. Then you do dot to byte, it takes bytes. So you convert the buffer to a byte, to vec to byte, to vec to vec or to byte to vec. So you convert the buffer to vector because a buffer is actually a byte, a buffer of bytes. Convert the buffer to vector. So this is how we would create if I wanted to create this same account, but the account is owned by this transfer hook program. I will do it this way, right? So this is the way I will do it to create the account. Tell me to pass this account to this instruction, but I'm the owner of the account. So you just pass the seeds here this way, right? So but we're not doing that. We are using the seeds from a different account. So we use this. I've broken everything. Yep, fixed everything. Yeah. So this is what we use. I'm saying anytime I want to initialize this account, I'm initializing the account and I'm saying every transfer that is coming to this account must provide the whitelist account. Simple and straightforward. Then, so we have talked about the two instructions in the token program, meaning the transfer hook, the initialize the transfer hook itself, and initialize the extra account meta on it. So now the next thing which we've explained is explaining again detail how these instructions actually complete to that. So the first instruction I want to do, I think I ordered them by it's ordered by it's ordered. So first one is I think you should really create vaults by precedence, which comes first. Yes, you create the vault because inside the create vault, and let me explain all the instructions that are them. You might see some things are redundant, but it just gets the work done, right? So inside these vault operations, we have a single instruction, which is the create vault instruction here. So we're doing here. Before what we're just doing there, just creating the vault state. We have a mint, we have an owner, and the vault bump. That's what we're doing here. And so we're just checking. This is actually redundant too. But it's cool. At least we're doing check. You cannot do too much check. So just cannot do too much. So I was trying to explain the accounts that are needed for this. So inside the vault operations, to create the vault, we need to pass because we need to store the mint, right? Pass the mint, and here I'm actually doing two things. I'm creating the mint. If you would do this off chain without anchor, but if you do it on chain without anchor, it's still going to be a pain in the ass. And if you are doing it off chain, it's still even with TypeScript, it's still a pain in the ass because you have to stack up instructions on top of each other. But with anchor and the constraints, it's straightforward for you to just do. So I'm initializing an account. I'm initializing an account. I'm saying the decimals is 9. The authority is this signer, the admin. And this token should have an extension of transfer hook. Should have a transfer hook extension, right? And the authority is still this signer. And that same token should have the transfer hook that it is calling is at this program ID. Straightforward, right? So I'm initializing an account, a mint. I'm creating a mint, setting the payer, setting the decimal, setting the authority. I'm telling the program, telling Anchor to help me make sure that the program ID for this mint, I mean the program ID for the transfer hook ID is this or is this guy here. This hook program ID is the program ID of this transfer hook. That should be AUG. What is it? Should be AUGB. Yes, OGB. So that's the transfer hook for that's the transfer hook program ID for that instruction. I'm just telling it, create this account for me, create the mint account for me, and this is the program ID. So wherever you are interacting with this mint token, you have to reference this guy, or you have to satisfy all the constraints that are inside this program, else transfer will fail. Straightforward and simple, right? Good. And hook program ID. So that's what I'm passing in the hook program ID. I'll pass the account, which is the other account. Then we have to do evolve states because we want to create evolve states, right? Initializing evolve states. The payer is the admin. The seeds is the mint of the token, and vault seed. Vault seed is just vault. Okay, it's from other places. Vault. B a byte of vault. How the vault seed is. Then the space is vault discriminator.len. That should be 8 plus in this space of the vault. Just creating this, right. So now what I was saying is now because it's the first time I'm creating the account, I'm setting a bump. I'm telling Anchor to help me derive the bump because that's the first time I can't know the bump of without creating the account. So I'm telling Anchor, bro, create the bump. Tell me what the bump is. Help me derive the bump. Find program addressing and tell me what the bump is and use it for this account, right? And you see that immediately I do this inside my instruction, I'm saving the bump. So this is the bump.vault state, bump dot vault state. I'm getting that bump and I'm saving it. So next time I want to use the same vault state, I don't have to derive the bump again and waste CUs. I can just get it from there, right? So straightforward and so. And so the vault ATA, that's the token address for this vault because when they are sending more tokens to the vault, the vault is not storing this. The vault state is the authority. So the vault state in this place is the escrow that has authority over this vault. Simple and straightforward. So let's do it this way. This is the vault ATA as associated with this vault, and the vault is the authority. That means the vault, this account can transfer tokens from this account. Tokens that are living in this account, and the only person that can transfer is this vault state, right? So that's I was talking about files and structure about Solana works. That's how it works. Mm, then what else? What else? What else? Authority, asserting the authority to that. Talking about the mint, asserting the payer. So also, but this vault ATA, yeah, everywhere. Okay, this is a vault ATA. You're not saving it, right? So there's no bump anywhere. Right? There's no. This is an associated. This is your wallet. This is your address for receiving. On Solana, if you have your normal wallet address, you can't tokens cannot live inside that wallet address. You have to create an associated token account for that token. I say I have this is me now. You want to give me something hot. I cannot hold something hot. But I have a cup that can hold something hot. You put it inside my cup. That cup belongs to me. So that's basically what an ATA is. An ATA helps you keep your tokens. And only you have authority over that ATA, basically. So that's what this is about. So this is the vault state and this is the vault ATA. And only the vault has authority to transfer tokens that are in the ATA. Simple. System program because we are creating an account and doing it. Token programs, system programs because we are initializing the account and because we are doing yeah, that's basically the reason why we're using system program. Associated token program because we are doing associated token blah 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 associated token blah blah blah. Token program because we are transferring tokens. Are we even transferring tokens? No. So how do we have token program? So why? I still don't reason why it's there, but leave it the way it is. All right, so I've explained what creating the vault is. Let's go to the deposit and withdraw. So deposit and withdraw. Save this for last. This is a whole lot of stuff. So Grey vault, mint token. Let's go to mint. Yeah, mint is still a happy place. So remember, initially I initialized the mint in the vault. So now I'm now minting the tokens to myself. I'm creating tokens for me. I'm sending it to me because I'm the admin, right? So I will specify that it's mutable. The mint is mutable, and I'm saying confirm that the decimals is 9. Confirm that the authority is user. Then confirm that it has this authority of the transfer hook, and confirm that it has this program ID as the hook ID, right? So that's what I'm telling you to do. What else? What else? What else? What else? So the source token account. Source token account is my token account. Me as the admin, I have a token account. I'm passing my token account here where I want my the minted tokens to come and live. Right. Like I said, the minted token cannot stay in your system account. That should stay in an associated token account. This is my associated token account of the source because I'm the source. Then extra account meta list. Extra account meta list, like I said, is the account that has information about all the extra accounts that you are going to be using in this information, in this instruction rather. So it's a transfer hook, it's a whatever it is. So now the whitelist is our guy, right? Have I created the whitelist anywhere? No. So I'm deriving the bump here, right? No, I have created this whitelist, so I should not even use bump. I should do bump equals bump dot whitelist because I have saved it somewhere. Have I saved this bump somewhere? Let me check. Let me check. Let me check. After create in the create vault whitelist. Okay, okay. This is the first time I'm creating it. I see. So yeah, the reason why I'm just leaving it the way it is this way is I'm creating it. I do not actually need it referenced anyway. I think I'm using it for what am I using this block list for? I'm using this for absolutely nothing. So I can remove this. I'm not using it anywhere there. So this was just waste of CUs, right? I'm just wasting CUs here, essentially. So I can remove that. Yeah, I can remove that. And let me take it back. I think it's better this way. You guys can see, right? Let me know in the chat if I should increase the size of the font or I should leave it as it is. So I was saying I actually do not need this anywhere here because I'm not saving it here. I'm not doing anything with it. I just added it. Waste of CUs. So the authority, what I'm doing here is minting the tokens to myself. And I forgot to say, if you are creating a vault, right? If if you do not want to initialize the mint right here, you would have written like 50 to 70 lines of code just to make sure you create the account. You set the transfer hook on the account, you set the ID of the transfer hook, you tell the mint, you would have written like 60 to 70 lines of code. But with this constraint, you don't have to do that. You just set it there and it does all the work for you under the hood drive. So yeah. So authority, then the mint of the token account, then who are you minting this token to? I'm minting to myself, of course. And because I'm the authority, I can mint to myself, right? So the authority of the instruction, the authority of the mint will be the only one to mint the transfer to themselves. I'm just doing a mint to. There's a mint to and there's a mint to checked. Mint to checked, make sure you put in consideration the decimals. And yes, I'm also doing mint to checked. So I'm going to specify the mint that I am minting. That came out wrong. The mint is specifying the mint to and the authority. I think it's the authority that I need to know. It's because of the mint. That's why this mint to checked. Or a regular mint to does authority mint and two. But transfer checked. If it's transfer checked, you will put the decimals of the transfer. You put what else? It's checking a lot of things. It's checking a lot of things. Basically. It's just checking to make sure I don't making a mistake. Like now, you don't have this place, this amount here. You don't have to put in. If you want to transfer 100 tokens, you just put 100 tokens. You don't have to put. If you have 9 decimals, you don't have to put 100 and 9 decimals. Just put 100. it will get the remaining from this decimals, right? So yeah, that's what that meant to checked does. Checks and checks. What else? What else? What else? What else? What else? What else? Done, create, we don't means. Let's go to deposit should be last because that is a whole lot of boilerplate code that's there. Yeah, then the whitelist operation. There are two whitelist operations. Add to the whitelist, then remove from the whitelist. So as an admin, I can add you to the whitelist and I can remove it from the whitelist. Basically straightforward. What I'm doing is check if you're actually existing in the VEC already. If you are not, then it will create your account for you inside that VEC to push you to the VEC and specify that your amount is zero, right? So if public key is none, so if this is not a valid address, which whitelist account that I should have got. So if there's no admin in this case, this is where I'm creating the whitelist. I'm creating the whitelist account here. I'm saving the state of the whitelist account. Right? So initially when I create it, to be zero, no, its admin will be an empty public key, then bomb two will be zero. But now that I'm checking if admin is an empty public key, it is an empty public key because the first time I'm creating, if this is the first time I'm creating it, because I not do initialize whitelist, add whitelist, and remove from whitelist. I do just add whitelist and remove from whitelist. So in the add to whitelist, I'm checking if this account is empty first. If it's empty first, I just save the admin and the bump there. So doing two things at the same time, and then do add the person to the whitelist. Same thing for removing from the whitelist, but in the opposite direction. So what are we doing here? See now I'm doing a struct that has an array, a vector of public keys, an amount, and boolean. So now the beauty of it is whenever you want to add to the whitelist, you increase the size of the vector. Basically, I just paying for more space for the vector. If I want to add myself, I want to add another user, I need to expand that vector to fit the new user I'm putting in. And when I remove the user, I need to shrink it back, right? So what that is doing is just paying for more gas, and getting your gas back, paying for more rent and getting your rent back. So that's what that is doing, right? So the alloc whitelist, this guy is so we have sort of sorry. Account info is self the whitelist of account info. That's the whitelist account that are getting. Then we have the wallet entry size, just units. So each wallet entry is of size of the pub key and size of the uint. I made a mistake here. It should be size of the pub key, size of the amount, plus what's the size of a boolean? Boolean is one now. A boolean is just one. I think that's why it's not throwing any errors so far. But it should throw an error along the line. That's one. Yeah, yeah, it's an error along somewhere in the future. Because when all of those ones get choked up. So the reason why we're doing this is let's check the state of the whitelist. This whitelist guy. Check the state of the whitelist. You can see that we are keeping per address here. We are keeping pub key, the amount, and the boolean. If if this person is if the person is whitelisted or not, right? I think that should be one. Yeah, that should be one. Should be 32 plus 8 plus 1 plus 2. But okay, so that's us. Yeah, yes, so that. Then we check if this operation is adding. So you are going to specify in the realloc function. What realloc is doing is reallocating more space or removing space from it. So we specify that we are adding to this whitelist each account, right? We're going to do the account info equals self for whitelist. So we get the account of one entry. So if you are creating an account, one entry, right? You are going to do what's it called? I see why I got some errors later. And now I'm getting it's coming to me why those errors came up. So if you are creating an account, you have to specify the size of that account because you're actually creating it, right? So one account now, one tuple. No, we're doing a tuple of pub key, amount, and is whitelisted, right? So per entry, that's per tuple, you have to specify the size of the tuple. So the tuple size is the pub key size, the amount size, and if it is whitelisted, and the boolean size, right? So we are going to check if you are adding an account to the user to that struct at the moment. You're adding a new tuple. So if you're adding a new tuple, you get the tuple size. That's the length of the data initially plus this new whitelist entry size, right? The new tuple size you are getting. So we get the rent that's needed for that, the rent that's needed for the new account size, rent that's needed for the new account size. Then I'm going to subtract the new account size, the size, the amount that is inside this token, this account currently, the lamp that is inside the account currently, the amount of rent you paid currently. Then you subtract it from the amount that is required for that new account size. But the new account size we add all the size of the account currently. So we are getting lampos required is this, and we are removing from the extra lampos that is there. So we get the rent difference, right? Then we're just transferring that amount, the amount that is needed to increase the size of the account. We're transferring the amount to the accounts basically. So that's what we're doing there. CPI equals CPI context. So I just transfer the token, right? You transfer this is CPI context, right? From who to then the amount of what you're transferring. So that's what we're doing. So this one is CPI context the new, and the token it's okay. I'm trying to look for the program ID. Should be self dot token program. Yes, self dot system program. We're saying this is the program ID. If we're doing a token transfer to be the program ID of that token of the token program. So that's the program ID of the token program. And yeah. So now we're doing a sole transfer. So it's the program ID of a system program. So then we resize. All resize does is create the new size for this account. And we've gotten the new size, right? The new size is what's the new size? What's the new size? New account size. Yes, new account size is the initial amount that is required, the initial space of the account plus new space of the account, right? Initial space of the account plus new space of the account. That's the new account size. So we get the lamp cost for the total new account size. That's what we're doing here. And we're subtracting this from the amount that is currently there. Because you have paid some if you paid some existing lamp costs. So now we want to add more and we know the total size of A plus B. We know the total size of A plus B. Then we want to subtract B from A plus B. That's what we're doing here, right? So that's what we're doing here. And for shrinking it back, it is the reverse. So that's what we're doing and adding to add the account, then removing from the account. So next thing is the most important one, which is the depositing and the withdrawal. I ran into a lot of problems when trying to make this happen. I said the debugging spree was a whole lot. I was around 48 hours. Just get to work, try to debug it, eat, come back to it, go out, come back to it. Just basically working on this, right? Two 2 days straightforward, straight up. And the method that I later settled for, the other methods, right? First thing I'll say is First thing I'll say is um, a normal transfer, a normal Anchor SPL transfer will not work in this instance. In this instance, you try to do something like this transfer check that I was talking about. Try to do this transfer check, it will fail because at the moment this SPL token transfer interface does not have the capacity to add the extra accounts that you need for your transfer hook. You know, in any transfer, you need to pass the extra accounts that you need to that you need in the transfer hook. So at the moment, this will not go. Even if you are doing with remaining accounts, it will still fail for some reason. So this did not work. So the fix that some people had the issues, and the fix that was suggested was to use the Solana SPL token 2022 on chain. So there's an on chain method to make on chain transactions. So it's SPL token 2022 on chain. I tried this. This also did not work. But later I figured out why it did not work. But I've not reverted my code to make it work. The one that worked for me is what I'm still doing in this demo, right? So what worked for me is manually constructing the instruction. Yeah, just like how you do invoke worked for me, yeah. Because everything is invoke underneath, right? Basically. So you have a transfer instruction, token instruction from SPL 2022. Transfer checked. Now I'm using that transfer checked, the same transfer check from SPL 2022, but not on chain. This one is transfer checked. And I'm doing the token program ID, source public key. That's who is making the transfer. It means of a token destination is the vault, because I'm depositing to the vault. Then the authority pub key. Who is the authority? In this case, it is me, right? Because I'm going making transfer from my accounts. So are there other accounts? Is it a multi-sig? No. Then the amount I'm making transfer for, and the decimals of the means. So transfer check, you check the says token program ID, source pub key, means pub key, destination pub key, authority pub key, signer pub keys, amounts, and decimals. Denim. So stupid. So then after we've constructed this, then we add the extra accounts that we need. So here it would be you're adding the extra account meta list, you're adding the whitelist, right? So the extra account meta list, the whitelist, and you can also add the program ID. I did not add program ID here, but it went through successfully. Others added program ID. That's the token program ID, right? You add that here also if you want to do that and if you go. So now, then you now add, okay, I think the reason why it worked was because I added it here. Because I passed it as the extra account info. So it must be in the same order because source means authority, destination. No. I think source means destination, authority, program ID, extra account again, and the hook ID. This is the way it is ordered in your transfer hook. Don't forget, inside this transfer hook, inside this transfer hook, don't forget the transaction was ordered this way. Source token, user ETA, mint, destination, vote. The owner is the authority here. That's me, the sender. Extra account meta list, this guy, extra account meta list. Whitelist, whitelist. Then your hook program ID, which is definitely is not even needed there, right? So you could remove it. If you remove it, it might not work. I don't know. I have it here and it's working. So after I have this extra account, so and I invoke the instruction and I'm passing all the accounts that are required for the instruction straightforward. Alright. So this was the on-chain invoke transfer that I did that failed. I think I missed the step, that's why it failed, but I was not stable enough to debug further. This is what I'm sharing today is like hours hours of debugging, days of debugging. I was supposed to live stream yesterday, but I was still debugging yesterday, and I cannot do another debugging session again without you guys getting value from it. So I just like let me fix this and sort it out before I come back live, right? I was not even supposed to live stream yesterday. I wanted to live stream yesterday just to fill the gap, right? But yeah, that's not thing. Uh, Invoke, and I'm invoking the instruction, and after that, I'm doing the. I'll still clean all of this up probably. So after that, I'm doing the check to make sure once you make a transfer, you also get your entry get updated in the meta in the whitelist. So in the whitelist now, I'm checking if save the whitelist address. I'm looking for you that made the transfer, and I am adding an amount to the amount that you deposited basically. So what we're doing here is it's just this one is straightforward. This entry should have been because from from our server whitelist address dot ether. Yes, server dot whitelist dot address. You get the address is a vec of tuples, right? Three things. First thing is what's the first thing? First thing is the pub key of the user, right? So user ATA, I'm saving the ATA actually. User ATA, which is the pub key. Second one is the amount that user transferred. Yes, and the next one is whitelisted. So since you have those three things from why is this thing not indented properly? Uh, so you have those three things, right? And the only thing I needed there was the entry one. I only needed the amount. So that's why you are seeing entry one here. So this one would have just been amount equals amount checked add one. Yeah, so that's what this would have been and it would have worked. But since we are doing position of just like doing position finding at index of something, so that's what this is about. So at index one, at index wherever it is, at index one, let me revert it to what was the initially entry. So entry at index one is amount, right? So amount equals amount plus one plus any amount that you've added to the box. And in the withdrawal is the opposite. So I think that in this withdrawal I did it actually in yes I destructured. It's called destructure in JavaScript, right? I destructured it and got the exact thing that we needed. Address. I don't need this second one. I don't need this third one. So I just got only address, and I worked with address. I thought that's not even where I'm looking at. This is where I'm looking at. So I still did the same thing. Did I? Did I? No, I did it this way. So let's whatever balance, then whatever. I don't need this second one. I don't need this first one. I only need what's in the middle. And I was working with that. Balance equals balance the check sub. Yeah, so so that explains the whole thing. When you're depositing and you withdrawing. So let's get into the reason why we're here. What we should have jumped into last week because of time. So let's close all of this and open up the meaty stuff. The LiteSVM tests. Ha 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 ha. Sorry, I just can't control myself when I do that. Yes, LiteSVM test. This is not like bro. This is not LiteSVM test. Bro. It's not LiteSVM test. This is not LiteSVM test. This is LiteSVM test. So in the test, sadly, we have just a single file. Hold up, hear me out. It's not all bad, it's not all that bad, but it is. Okay, first thing, unused imports. Yeah, you can't blame me. You can actually. So now, the beautiful thing about LiteSVM, I'll talk about LiteSVM. Let me go to LiteSVM and show us what LiteSVM actually is about. LiteSVM Solana. GitHub LiteSVM Solana. What is it about? Yes, a light SVM, a lightweight Solana virtual machine, LiteSVM. LiteSVM is a fast and lightweight library for testing Solana programs. It works by creating an in-process Solana virtual machine optimized for program developers. I don't have to read everything else. So LiteSVM works in a way that if you are making your instruction transactions, you do not need to pull in the entire crate. Sorry, a minute. 1 minute. Back. So you don't have to pull in the entire. You have to pull in the entire crate. So initially, you would have just said to install Solana Solana program. Inside Solana program, you can have Solana keeper, Solana message, the whole crate, right? But no, you install individual crates that you need for the instruction, right? And the right versions. So now, first thing I'll say is if you are on version 0.7, sorry, if you are on Anchor 31.1, you want to use LiteSVM 0.7.1. What am I saying? Let me confirm. Mike made a post about it. Mike McCanna, if I can pull that up. Let me pull that up real quick. Um, 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 looking for the post. Looking for the post. I don't want to open Chrome, but I would have to open Chrome. I hope it doesn't clock my CPU. Mike McCanna. So, Mike, I'm trying to look for the particular post. Aha, there you are. Mike, welcome to the stage. So Mike made, was it Mike? Was it Mike I made the post? Was it Mike? We'll find out. Shall we not? We shall. Was it Mike? 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 You're talking about what I think Jacob made a post and was asking what are the things you like, are the things you don't like about Anchor 31. If someone has a link to that post, please just drop it in the in the chat. Please let me see. I want to point out something. It made a good list of I think 4 or 5 things. The project and cluster we're getting to V1. Yeah, yes, this post. This is the post I'm looking for. This is the tweet. This right here, guys, the tweet. What you need to know about the new, not the new Anchor 32, right? What you need to know about Anchor 32, right? So, cool. So you don't need. Well, that's not what we're talking about. So we're talking about the light SVM part. Talk about something about light SVM. So Anchor 32 and 31 family uses to. So you want to use Solana. You want to use light SVM 0.7.1. You want to use light SVM 0.7.1, right? You don't want to use 0.8 unless you have a lot of conflicting packages because the types that are required by one package is different, and the way things most things on 32.1 most things on Anchor on light SVM 0.8 is asynchronous in that way, if you say so. And the account types are, but one thing that you keep you know is the version of LiteSVM that you're using. You need to know what what version of packages are compatible with that. So how do you do that? Once you are certain of that this LiteSVM I'm using is compatible with my Anchor version, so you just look for the packages that are compatible with that Anchor version. So this is what I mean. So I go to create now. Let me check. I'll show you one create. I go to create, I go to create, I go to create, I go to create. Here you go. Create. Yeah. This is SPL token 22 V6 Before here, I was coming from, yes, Anchor. I'm using Anchor SPL 0.31 right on Anchor 31, right? So I'm using SPL 31, Anchor Lang 31. Any package that you're using in your LiteSVM should be packages that are compatible with this Anchor version currently. If you be using SPL 22, token 2022, it needs to be this exact version. If you be using group interface for any reason, if you be using meta interface for any reason, it has to be this version. Else you have dependencies issues, dev dependencies issues, right? So let's check what other thing would we need. Okay, anchor lang. If we're in anchor lang, you check the dependencies of anchor lang and see if whatever version, if you need Solana program, it has definitely has to be this two. If you need Bosch, whatever reason you need Bosch for, if you need whatever you need, just make sure you're checking on this. It is actually the version that is compatible with what's here, and you're good to go. You're good to go. So that was what I did to come up with this. Where's my code? Lost. With this list of dev dependencies. LiteSVM 7.1, 0.7.1, Solana address one. This does really doesn't matter actually. This one is not does not there's no breaking changes, no large much breaking changes here. Solana hash, Solana instruction, Solana pub key, then your transfer hook. Yes. The reason why I'm using transfer hook here is because I needed it inside my token. No, I only needed this as dev dependency, right? I needed this crate inside my dev dependency because inside that I'm writing all the tests for all instructions inside the same file, inside the same mod.rs for the test. So I need to be able to communicate with the crates that are inside my SPL token, my transfer hook rather. So I needed that transfer hook. The file is called transfer hook, and where it is there are different packages actually. Those are different packages. It's not like I did anchor new. I did two different anchor inits, and that was like something I should have not have done. I should have just done anchor new than existing directory and add both of them. Right? But this works too. Just have to go up one more step. The first slash, the first slash, the first slash, and get to exactly where the thing is. I don't need this feature CPI because I don't want to do. I don't need this feature CPI. I just needed that one straightforward. So I was pointing to this SPL 22. This okay. What I showed now was this Solana signer. So all of these dependencies that is dev dependencies has to be the same, has to be very compatible with okay, I showed this SPL token 2022 now. So what I'm using has to be this six. I think this should even be six, not nine. So um the package I showed now are compatible with 31.1 because 31.1 actually depends on them, right? So you see that I'm using these packages individually. The Solana keeper, Solana signer. Normally you would have everything from I think from Anchor Lang or Solana program. Which one is it in? Mostly you have all of that inside a single program. But for LiteSVM, you have to use those things individually and get on with it. So now let's get into the tests. I was looking at what was I looking at if I digressed? Okay, on use dependencies. I told you why we needed latest Solana address, Solana instruction as a separate crate, Solana keeper as a separate crate, Solana signer as a separate crate, transaction as a separate crate, and instruction. Where's instruction? Instruction data, instruction. I used instruction. Okay, this instruction. Solana instruction. I did not use the Solana instruction, the instruction from Anchor Lang. You will have incompatible packages, incompatible types, structs. So you have to use the one that LiteSVM expects you to use. That is inside this independent crate, not the one inside Anchor Lang or the one inside Anchor SPL. It has to be the original one that these guys are using. So you get, I'm not trying to drive at that point now, so you'll know why we have all these individual crates installed here. Uh, so this is me. This is me. This is me going into a whole lot of backward and front just to make this out. That was me debugging for hours straight. I was using incompatible packages, and two pub keys were not the same. So I had to do implementation for a pub key. The implementation here is doing converting a pub key to a pub key, and converting an address to a converting a pub key to a pub key, anything to a pub key, converting anything to an address, even if it's a pub key before, because there are different crates. The types don't just it's that's Rust thing. The types don't just collide, right? So I was doing implementation today. I was like, bro, instead of me doing all of this, I have to do something for address to address, address to pub key. It's crazy. Instead of doing all of this, let me just keep it there for safekeeping, for keepsakes. So instead of that, just use what it actually expects you to use. The pub key is from, I think I'm using Anchor Lang pub key because the Anchor Lang is compatible. Instruction, then keep transaction. Okay, so setting up your LiteSVM instance. One thing you should know is two states in a LiteSVM instance do not share information. Like, what do I mean? Two test states. If I have a test state here, if I have a test, and I say fn say hi, say hi, you should not return anything. So if I needed, let's say I needed, let's see, I needed, if I say let's breeze is windy, to give me errors because it is outside the crate, it needs to be const, wherever that's. So if I say later and I say I breeze equals what state of breeze do I have again? Whirlwind, whirlwind. And I say I have another function. Let me just do quickly. I have another function that says say hello, and here I want to access the state of breeze. The thing is, if I have an instance here and in my program I'm creating an account here. Let me be realistic now. Let me do um let's say the program name is program dot create account. So I have this here, program dot create account. Then in my mind I feel okay, I have created this program here already. So when I'm coming to this next test create, when I come to this next test create, since if I do say hi here, even if I do say hi here and I try to get breeze now, if I try to get breeze now, MSG breeze breeze. Why did I remove breeze? My bad. If I try to get breeze here, because I set breeze to something else here. The fact that I did this say I does not mean this say hello will have breeze to be programmed or create accounts. Understand? The fact that, let me remove the breeze if I don't need the breeze. The fact that, let's say I have inside say I'm creating an account inside say I. Then I now try to get that same account. Let's create an account equals, and I expect program dot created account. This will not exist. Even if I did this, because this is in this creates this test instance is in a different um instance. This is a different crate on, let me call it crate, right? This is a okay. This is a different pipeline. This is a different pipeline. Even if I call the pipeline inside this place, the state of this does not get inherited by this. So if I need this, if anything I need this, I need to recall this guy here, right? But there's a way to share states if you need. So instead of always creating stuff, there's a way to share states, right? So that's basically what I wanted to point out. So if you want to share states, there is a way to do it. You have a setup function, right? A public set function that you use to set up your instance, and this function can return stuff. That is the way out. If your test function cannot return stuff, what if you just said, now I want to return whatever. Then your new function you now call test full deposit and expect you cannot return. If I save this, you throw an error, okay, whatever I meant. If you throw an error, let me say return pub key. Yeah, throw an error. Trace bound pub key dimension and blah 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 blah. Yes. I'm trying so hard to make this thing fail. It's not what is. I have to do a lot of things to make this fail. What I'm pointing at right here is that this cannot return anything apart from this. This function cannot return anything apart from this. Is it even returning this? Okay, yes, returning just unit. It's not returning anything, it's just returning a unit. Like okay, like how okay is on the Rust side, right? So this will not work. That would fail because it cannot return a value, a struct, a variable from a test. A test is just a unitary pipeline. It just exists. It just works. It does not share state with the caller. It just exists. It just happens. Yeah, because now that's how you can run this test separately. They are separate entities, but you can reuse state. Now, what I did was I'm creating an SVM instance, a light SVM instance. Then I'm doing a basic keyword of new. You know that now. So I'm creating an admin account here. I'm airdropping some amount into that user. So it's just straightforward. SVM.airdrop, who is getting the airdrop, and how much you're airdropping. So that's what I'm doing here, right? Then now, once you have your account that you need, you need to load the state of your account, state of your program into LiteSVM. The LiteSVM is like its own SVM instance as existing in your program, in your on your PC. Its own SVM instance. So you can load the state of your program, you can load the SO file of your program directly into LiteSVM. So now I'm getting the path to your program SO file. I'm also loading the path to my transfer hook SO file because I have two programs I have to test here. See how easy and straightforward it is. Now, next thing I'm doing is reading the data. So I want to actually read to make sure that something actually exists in that part that I just resolved, right? So I'm doing the same thing for hook program also. SCD the file system, read and expect. So if it fails, just give me an error that failed to read SO file, failed to read hook program SO file. Then the next thing is okay. And I'm getting the program ID. The reason why I'm getting all of this is because I need to export it later, right? So I'm looking for the program ID, the SPL program ID, HCA program ID, system program ID, and so I'm creating a new mint because I need a new mint. The reason why I'm creating a new mint is because I need to reuse the mint everywhere I call, so I can have a reusable state function. So I have now to load that program that just I just read from your file structure to load it into your own SVM, your own virtual machine instance, your own virtual machine instance. What you do is SVM that add program. So SVM that add program, then the hook program, the program ID, the ID of that I did there. So this is This transfer program ID is, like I said, I am installing this as a dev dependency because I needed it inside the dev crate. So I needed the dev crate. I needed it inside this dev, inside this test as transfer hook, and I'm getting the ID of the crate. Simple. And for the program ID that I'm currently working on, because the test is inside the same crate, I'm just doing crate ID, ID from crate, and I'm exporting it as program ID. This one is transfer hook ID from transfer hook crate. Simple. And I'm getting transfer hook program ID and program ID. So I'm now loading. I just renaming it to look nicer, right? Snake case. So I'm renaming it here, and I'm adding it to the program. I'm adding it to my SVM. So basically, I could also get, if I have any other program that I need to use inside this same SVM, I can just load the states inside it, right? If it's a program that exists on mainnet, the program that exists on mainnet, the program that exists on devnet, I can also add it. I can fetch it. I'll fetch the account firstly, fetch the account from mainnet or devnet, get the states, then load it into the program just like this. I would have shown that, but let me just get to, let me see where I can show that. Inside Andre, yes, what am I looking at? What am I looking at? What am I looking at? I'm looking at, so whitelist transfer hook, whitelist transfer hook, Andre, whitelist transfer hook, whitelist transfer hook. I'm profiling Andre. So whitelist transfer hook, I think it's SQLite SVM. Yes, that was a very immediate example. Andre source instruction, no, source tests, not instruction, tests mod. So this is the exact way to do what I just said. Example on how to load an account from DevNet. So what I did was I have the RPC to DevNet here, and I'm just loading an account. So this is the address of the account, right? So you could load an account and attach it to whatever address you like. You can have, you can grind your own address and clone data from Radium AMM and let it be existing in your own grinded address. So you can just have any address basically. You can have an address. So from local net, from DevNet, I can fetch the account. So RPC clients, that's DevNet's RPC clients, dot get account and the account address. So this is the address that I want to get, right? So this is the account I'm targeting. First question. This is the account that I'm targeting. I'm targeting this account. It exists on DevNet. So once I've gotten the account, I can now set it to, see now I'm setting it to a different person here now. And I'm saying the data that I got from this account, I want it to belong to a new account that is existing on my SVM. So the SVM, don't forget the account, this payer account is this one that was created here, right? So I'm saying I want to override everything I created in my payer initially. My payer, I want to clean that account state. I want to pull data from DevNet into my local net and it should stay on this address. It's basically like I have an AMM, I have Radium, and I can clone Radium into my SVM right here and work with it. Basically, all the existing states that is inside that Radium account, I can clone it and put it here for all of their state accounts. Whether it's their CPMM, CPMM, ATAs, or CPMM states, configs, everything. You can have all these addresses, clone it into your SVM instance, and you work with it straightforward like that. So we have fetch the account. Then here I'm setting the account. This is where I want it to live, and this is the account structure. So the import for the account will be, if you want to add it, you can add anything you want to add there. But if you want it to be exactly the account that you fetched, to be the fetched account import, the data that exists on that account should be the exact data that you cloned. The owner is you, if you are the owner, right? So you are the owner of the account. Then, okay, the owner of the account is the owner of this account that you cloned. So if Radium was the owner, you will still want Radium to be the owner in this your profile, in this your program. Then you can just put fetch account of owner dot to byte. So pop key from that. Then executable. So you are checking if you can set I want this account to be executable or not. But yeah, since we're cloning exactly what was happening on DevNet, just passing it. Is that DevNet account executable? Yes, if it's executable, you just use the exact states that were in here. And the rent epoch of that account that you cloned, still using that same rent epoch here. So straightforward, just like cloning. It's basically cloning, copy pasting accounts from DevNet and making it exist in your own SVM instance and continuing to do everything else today. So enough talk. So back to yeah. So now what I did initially was I have this reusable state. I have this reusable state because I want to be able to reuse this. These are most data that will be reoccurring everywhere in my program, right? So I have this reusable state, ATA program, pub key, token program, the pub key, system program, the pub key, what ATA, what state, mint, admin. These are most of the accounts that will be reoccurring frequently, right? So I create a struct for it. And I'm saying in my setup, once I'm done with my setup, I need to return two things in a tuple. Return two things in a tuple. Then the first thing I'm returning is my LiteSVM instance that has all the loaded states, my LiteSVM instance basically. Then next thing I'm returning is this reusable data struct. So I'm returning two things. So at the end of my file, I'm returning LiteSVM instance and this tuple here. So before that, okay. My daughter. So ATA, I'm just getting the program ID of ATA, system program ID, but I'll be needing all of that everywhere I'm getting to, right? And if you still want to create some of those accounts outside here, you can create the account here. This state is shareable. Anything that inside your setup is shareable because you can return the value from it, right? So that's what I'm doing here. Test full deposit workflow. Let's meet SVM reusable data equals setup. So setup is the function that we created above right now. Yeah. And we return an SVM instance and reusable data. What I'm doing there is getting the SVM instance and the reusable data also from that same instance. And I'm indexing, I'm just putting a pointer to every instruction that's there, right? So create vault instruction is an instruction. Instruction is from Ancholang. It's an instruction. Ancholang, oh sorry, my bad. From Solana instruction, not Ancholang instruction. I said that initially and I forgot. So from Solana instruction. And so we have this instruction here, and we are doing accessing the program ID for the instruction. It's just basically creating an instruction that will be converted into a transaction that will be broadcasted. How about then? So the account for this instruction, the beautiful thing about LiteSVM is you can use the same create state that you defined already in your program. That's the beauty of testing in Rust. Your test can exist and share states. But if you're writing LiteSVM or maybe Web3.js or LiteSVM TypeScript, you have to know this is the pub key, this is an address, this is a key pair, this is all of those back and forth, right? And you wait for Anchor to tell you the account you expect. So program, how was it in the program instance dot program dot methods, program dot methods dot whatever you want to do, right? Then you are going to get the how's it in TypeScript again? Program dot method name. Then inside the accounts, you can now see all the accounts that Anchor is exporting for you to use. Excuse me. So that's the way it works basically in TypeScript, right? And sometimes Anchor might not serialize the data correctly. You might make you is mostly it's going to be you that made the mistake, right? You made a mistake somewhere. You use circular dependency. Anchor is not expecting, it's not deserializing the account properly. You want to pass the account, but Anchor is telling you you cannot pass this account here. Anchor TypeScript is telling you cannot pass this account here. I'm going to handle this for you. But the handling, when you now send the instruction is now telling you not enough account. Like, I wanted to pass this account, you told me not to pass it. Now you're telling me not enough account. All of that headache can sort it out with this because you know exactly if you're using account partial, it will work right. So all of that headache, you can avoid that with these accounts, right? Create accounts, create accounts, then vault account. This ones are the account that you defined inside your instructions here. So if I come to my instruction, then vault operation is inside create vault. Yes, vault operation. So all the accounts I need here, owner, mint, open program ID, vault, it already knows because I've created it somewhere before, right? So I can just reuse that create account that I have, vault operations, and pass in the exact. So you know exactly what you expect, right? You already know what you expect because it's a struct, and the struct will not allow you go if you don't fulfill all the accounts that are required inside the struct, right? So that's what we're doing. And the data is, and after you've done that, your account has to be account methods. Has to be account methods. You convert it to account methods. Account is create account location dot to account methods. Then also your data has to be the data. So your data is create instruction, not create account now. Your data is instruction. It's just account should be account is account. Then data is instructions. The data you need to work with the instruction lives inside the instruction, right? And it is called create vault. So in our create vault, we're not expecting any instruction. We're not expecting any data for that instruction. So we leave it as empty and we'll put the data there. Straightforward. If you do, I think if you leave this out, it will still work. I don't know. So then we get the recent blockage from SVM, our SVM instance, SVM latest blockage. Then we also do new signed with payer. That's because we're creating a transaction. Now this is now a transaction that I want to submit to the blockchain, to our blockchain, our SVM instance. So transaction, new signed with payer, create this is the instruction. So the instructions, if you have multiple instructions, so it's an array, it's a vec of instructions. Then this who is the authority for this instruction or this transaction that are sending. I think is authority. Yeah, another thing about this dev environment is it does not help you with your what's it called? It's not LinkedIn. Your linter does not work here, so you cannot pick into what the account is. Only if you are using a dependency, not a dev dependency. So we're using this place now. Anchor lang is a dependency, not a dev dependency, right? So I can pick here and to show me what is inside of that thing. But with these ones that are dev dependencies, if you pick to not show you anything, so you have no help. You just have to go over. I don't know if there's a fix for it right now. We just have to check the docs and see. It's hard enough trying to write your instructions in Rust, then trying to read the docs. But you have to read the docs anyway. Though. Then let's get back to what we're talking about. Get the recent block cache, create a transaction. So who is the signer for this? Since in our instruction we said we want to create the mint, we want to initialize the mint inside that same instruction, right? So you have to pass the mint as a signer too. Just like you want to create a mint for an SPL token, you pass the mint as a signer and the person making the transaction right as signer too. That's what we're doing here. Transaction, then we do SVM dot send transaction dot unwrap. Simple and straightforward. You could also build it as a message, then broadcast the message, sign the message, broadcast the message. But I just like to, since it's just single step instruction, I just do instruction, transaction, send. Some people like to do instruction, transaction, message, then send. Same thing, gets the work done right. So, but some instances you want to get a message, not a transaction. It depends on what you are doing, but most times you just want to send a transaction straightforward, right? So then we want to validate that what we did actually went right. So we have this svm.get account. You cannot pick intelligence does not work because we're using it as a dev dependency. So we want to confirm that the transaction we made actually went through, right? So fetch vault state is we get the account of the vault state. We're getting that vault state from SVM. Since we've created the account now, we want to fetch it back from SVM. So SVM.get account, then the state of that account they are fetching, the pub key of the account they are fetching, and unwrap it. Once you fetch it, you unwrap it. So you now, so what type of account is it? Is a vault state account, right? And don't forget that we are inside the same Rust environment, so we can use the vault state from that environment. So we have create state vault, try deserialize. So we can try, we expect, because we know that it's a vault, we can expect it to deserialize this account properly, because this account is also a vault account. And we pass in the vault account data as ref, unwrap it. And now we are setting that the fetch vault state mint, because we set the mint inside the vault state, right? Don't forget in our instruction, we set the mint inside the vault state. When we create the vault here, we are setting the mint vault, the setting now, we're setting the mint, we're setting the owner, we're setting the vault one. So we want to make sure that the mint that was set, if it actually got set, is actually the mint that we pass from the client. So assets equal fetch vault state dot mint dot key, then reusable data dot mint dot pop key. So if they are equal, we are sure that our account was successful, right? We fetched the account state successfully. We created the vault state on chain successfully. We initialized, we set the data successfully, right? And we are good to go. Then the next thing is we also fetch just another assertion to check that the owner is actually the owner that we set, because the admin should be the owner, and we set it in the instruction that the admin should be the owner. So we do this also. We assert that are equal, and what else? What else? What else? What else? Okay, now, and okay, I'm not getting. I'm trying to see what data length this is. If so, the only thing that should get printed out for this first instruction is mint account length, mint data length, right? So let's test that. Anchor tests. No, sorry. CD week one test challenge. And anchor test. There are still some failing ones that I just need to change the pub key, the seed derivation. I think instruction 9 or instruction 8, that's it down below. So those ones will fail. One of them will fail. So the whole thing should fail because one failed. But the state that leads to that, we'll see our logs. So I want to check the logs, the message that we did there, meet data length, meet data, yes, length. So when we scroll up, we see, so the mean data length is 234, 234, mean data length 234, right? All good. Then I think I had this issue with the mint. Maybe SVM, where SVM is serializing the data, or it might be a thing with Anchor SPL. Anchor SPL expects the mint that has a token extension to be a specific size, to be above a specific size. That means there is actually a mint, a transfer hook on it. But it should also get to the next. Let me get to that right now. So yeah, so we see this works now. So the next instruction we want to do is transfer hook. So once we initialize transfer hook, then the one thing I usually do is when I want to make an instruction, I already have the instruction create and then the account. So the account will tell me the accounts that I need. Hmm. The accounts instruction, the instruction account will tell me the account that I need. Yes, that's the way to put it. So this instruction account, the instruction is initialize transfer hook, right? So the account creates here, you need a couple of accounts, extra account meta list, mint, payer, and step program. So I already have these three reusable. So the one I need to create now is this extra account meta list, right? So that's what I did here. Let extra account meta list is pub key, find program address, and the address the seed that I used to find that is extra account meta and the mint, extra account meta and mint. That's the static, that's the way extra account meta are created for mint. Extra account metas and mint. Then the ID. Don't forget, we said the only two instructions that we have on the transfer hook is initialize extra account meta and the transfer hook instruction. Those are the only two instructions that are in the transfer hook. Every other instruction are on the vault. So we have to use the program ID of the transfer hook. That's why I had to install. That's install. That's why I had to import the transfer hook program ID initially. Now we have that here, and I'm getting the first because if you do create extra account meta, if you do program find program address, you're going to get a tuple of pub key and the bump. So I only need the pub key right now. I don't need the bump, right? So I just do dot zero, same thing as then I now have just this pub key, this bump. So I can just say I don't need that. So I can do bump if I need it. Bump is of type PH because it's giving me two things, right? So I'll just do dot zero instead. Same thing as saying at position at index zero in TypeScript, like this. If I do this, it tell me a warning. It will give me a warning, an error actually. Nope. Like this. I save, throw a warning. That actually did not throw. Okay, throw warning. To access tuple elements, use dot zero or use dot one. So instead of at index zero, just Rust way of doing Rust, right? At index zero. There you go. Satisfied? Yes, satisfied. Then now I have all the accounts. Extra account meta list means it's reusable. Payer is reusable from all the way from yeah, reusable data. What I did was I just put all of the instructions inside the single test. How I said, don't hang me, but yeah, I'll put. Mm, then initialize transfer hook instruction, the hook program ID, because that is where the initialize transfer hook instruction lives inside the hook program. Then the data, I'm not passing any data also. Transfer hook instruction. I'm not passing any instruction data, so leave that as empty. Just data. Then we also broadcast this transaction. The instruction is the transfer hook instruction. Who is the payer? Who is the authority here? Admin. Then who is signing? Admin is also signing. In recent block hash. Simple and straightforward. To SVM does send transaction the unwrap. So now I'm now getting the new state of this meta state list. So new state of metadata list. So I did initialize meta extra account meta list, right? I'm getting the state of the vault. How am I getting the state of the vault? This state of meta list of data should be svm.get account vault state. What instruction is this? This is initialize transfer hook. I was supposed to get the account of what account are you using to get? Is there any way to confirm that this one through? There is a way, but that's what I was trying to do here. I think because of I just skipped that. Hmm. So I'm just logging out the account state here to be sure that the account actually got created on chain. Right, I was supposed to just log out instead of reading data.vault state, I just log out extra account meta list. So I'll fetch extra account meta list here. So it should be extra account meta list here. Extra account meta list. Will work. So let's log that now. So this one that was logged before was vault state. So let's log out extra account meta list now. We're almost done. Just show us all of the instructions step by step. I think I've explained the important part of it though. So yes, so now this is the account of Metalist. So that means the Metalist account was created. All good. We're good to go. So there's data existing inside this account. So I wanted to deserialize it, but I don't have time to do that. To see what is actually existing inside the account state. But there should be some data inside the account state, right? But I don't have time to do that. What else? What else? What else? What else? What else? So I'll move to the next instruction. Add the user to whitelist. Basically, straightforward. getting the whitelist state account, the whitelist PDA account, PDA, creating a new user that I want to add to this whitelist, airdrop the user some amount of tokens if he needs it. He does not even need it yet. Does not need it yet. Then getting an ATA for the user. So this is what we're doing here. Getting the ATA of the user associated token from the imported crate. So this one is an Anchor SPL crate, so it can resolve. It will resolve for you because it's a main crate, not a dev crate, right? It's a main dependency, not a dev dependency. Why am I saying crate? Okay, so it will resolve this one for you. To get associated token address with program ID, this is the wallet address for the token for the address I'm trying to get. This is the mint, and this is the program ID, the normal token program ID. So I will get the associated token address straightforward and simple, right? So now I want to add to the whitelist. So everything I want to do is get the accounts first. So what account do I need for this instruction? From this whitelist operation, whitelist key, vault, admin, and system program. We have the system program reusable, we have the admin reusable, we have the vault reusable, and that's why we had to create whitelist. But that's the only thing that was not reusable. So that's why we created this whitelist here. Right. So backward from the future. Yeah. Then yes. So we also pass, but in this one now, for this instruction, we have to pass some data. The data we have to pass, the argument we have to pass is the address that we are adding to the whitelist and the mint of the user that we're adding to the whitelist. This is typographical. Is it? Just let it go. It works. If I do this, it's a trial and error, but it is named underscore mint. I mistakenly named it underscore mint because I thought I did not need it. So now, the credit express me to call it underscore mint. I just did that to silence the errors. Now the errors are silencing me. Okay, and create instruction, get the data. So it's just basically going over this thing over and over and over again. It's basically transaction new signed with payer. The instruction that I'm making the instruction that I want to send that you just built. So the admin is also the signer. The authority here is also the admin is also signing, but the admin must sign, else you cannot add yourself to the whitelist. Only admin can add someone to the whitelist. And recent blockers. Send also. So now the check we're doing here is getting the whitelist account now. Then checking if I'm deserializing it just like I did before. Try deserialize the data. So now I'm checking because I've already deserialized that data. It is a whitelist account, a whitelist state. And in the whitelist state, I have a function, a method called contains address. Inside, you check whitelist. You see, inside this struct, we have an implementation helper here that says contains address, is whitelisted. So this helper functions you can reuse it. Just makes life easy. Writing a program in Rust and using Rust is not easy to write, but it makes life easy when you once you get writing it. Right? That's how Rust is. Rust is not easy to learn, but it just makes things work well once we start writing them. So we have a dot contains address here. We pass in the address that we are looking at, and it checks if it contains the address. True, it returns a boolean, right? So we assert that it contains address because to return a bool, else you were not successfully added to the whitelist. And I'm also logging it out to check if the user actually exists. So contains address, which is a boolean. If it contains you true, you should see contains you true. Where is it? Contains you true. And just on and on and on and on and on and on and on. So one thing we do, we're almost at the end of this live stream of time. What else? What else? Every other thing is just going through, going through, going through. One thing we'll do to open up, excuse me, to open up Friday. Today is Wednesday, right? Today is Wednesday. So what we will do to open up Friday is I want a number of people that will be available to go over this and explain what's going on in the remaining instructions. So that keeps us in check, right? To just have this feedback loop. So I'll share the link to this repo. Is have I pushed it onto J git status? Ah, what did I modify? It works. So cd dot- dot- git add git status. Yep. Git commit. I say yeah, fix demo testing. I demo testing go. Then git push demo testing go to main. So what we want to do is just let me see a show of hands. Let me see a show of hands. People that would like to go over. So what you want to go over is this remaining instructions. You would be at the backstage with me on Friday. Yeah, let's do that. So we'll just go over these instructions that I've learned. And Friday would be about magic block. Yeah, magic block. Friday would be about magic block. Writing random, maybe just something basic. Might not be basic, but it should be basic. Randomized VRF, the ER, the ephemeral rollup, and what else will it be about? Friday will be about magic block. Today was supposed to be about magic block, but since we've not covered this, we've not completed the test for this, so I just had to push that to Friday. So Friday will be about magic block, everything magic block, right? Everything magic block. What else? What else? What else? There's something else, but yeah, Friday though. So what you want to do is go over this. Make sure you understand. Just you get the flow. Come with questions. So the next on Friday, let me see a show of hands. If you would like to be a part of that, just drop a I in the DM in the chat. Wherever I'm chatting from, I don't even know. I think the only one I can see now is X and X and YouTube. I cannot see if you're chatting from Switch because Switch is a custom RTMP that I added to the backstage here. So just what I was trying to point out is if you'd like to do what to be at the backstage, you'd like to go over this repository. Let me paste the link. And that's the annoying thing. I can't paste the link. Yeah. Wow. Okay, someone did I think someone made a comment. Uh, inspiration, inspiring people. Not okay. I'm not a token extension expert yet. I would love to have one of these days. I love to have Andy on the call one of these days, and have go over token. That would be token extensions extravaganza. It should just be all about token extensions, token transfer hook extension. The rest there like there are a number of extensions, a number of them, all different transfer hooks you can work with. To be what he has done in one of his videos. Let's talk about it on the call to you guys. The jam. This is supposed dev life is tedious to some extent, so we have to make it fun, right? Come keep like Jeff will say, keep imposter syndrome at the door, leave it at the door, keep it, just forget about it there and just vibe to this. I was not here to last week. Like last week, I could barely understand what I was trying to do, but now I'm explaining it to you. So it is the more you get to do these things, yeah. So let's see. Just drop a chat in the live stream, not in the on the post. If you drop a chat on the post, I'll not be able to see it here in the backstage. Drop a chat on the live stream. I think some people dams will have Gorav will be here. Gorav will be here. Then else, I think it's let me check Twitter again. Let me check X again. Some people that want to be part of this. Diego, is Diego. Where is Diego? Where is Diego? Okay, this is Diego. Does Diego would also like okay, Diego did not comment right now. Okay, Diego would also be part of so we have our lucky winners. We have Gorav, we have Diego, And we have Anant. Yes, Anant would also be in the backstage. So we'll just be talking about what we before we get into Magic Block. Talk about these transfer hooks, questions, how would we approach this kind of situation? Everything transfer hooks, right? So that's what I want to do on Friday. You guys are still not chatting. Drop chat. It's not okay. I promise you, no, I'm not promising, but you may not open your mic if you don't want to. You may not open your camera if you don't want to. Just let people see your profile picture like mine, and they'll know that yeah, someone this guy from Twitter, bro. I saw you on the Anchor founder. Are you an Anchor founder? Like, yeah, I'm an Anchor founder. Yeah, everybody's cool. So it's good to be cool like that, bro. Yeah. That's it. So thank you all for joining today's space. This is the Anchor founder, and this is me signing out. Thank you. See you on Friday. Yeah.